Hi, this is my Rally Championship Management System. This is a regular Java program. The goal of this task is to manage drivers, rally cars, race results, and championship statistics. In my solution, I used object-oriented design, static members and methods, and synonym partner. I will briefly show the main idea of each class and then demonstrate the output. I will start with main Java because this is the entry point of the whole program. In this file, I create championship manager singleton first. Then I create rally cars and drivers. After that, I register the drivers into the championship manager. Next, I simulate two races with different surfaces. The first race is on gravel, and the second race is on asphalt. Between the races, I also demonstrate the car switching, which is required by the task. At the end of the program, I print the championship standings, the leader, the statistics, the race results, and the car performance ratings. So main Java controls the whole program flow, but it does not contain too much business logic by itself. Here I use dependence injection by passing a car object into each driver. And this is my driver class. A driver has a name, a country, total points, and a rally car. The class also includes methods like add points and switch car. I also use a static field called total drivers. This helped me track on how many drivers are registered in championship. This class has one clear responsibility. It, it represents one driver and stores driver related data. This is also shows static member usage because the task asks us to use static data where it's right. And this file shows the car hierarchy. Real Java is an abstract class. It stores the common data of all rally cars, such as make, model, and horsepower. Then I created two subclasses. Then I created two subclasses, Gro- gravel car and asphalt car. They both extend rally car, but they use different performance formulas. This design follows inheritance and abstraction. It also follows the open or closed principle because I can add another car tab later without changing the parent classes too much. And this class is very important because it implements the singleton partner. I made the constructor private and I use a static instance field. Then I provide a public static get instance method, so only one championship manager object and exit. This class stores the list of drivers and the list of race results. It also provides static helper method to get championship standings, find the leader, and calculate the total championship points. So this class manages the whole championship in one central place, which is exactly what the task asks for. Here I use an interface called race results. The interface defines the basic behavior for recording and retrieving race results. Then I created rally race results as a concrete implementation. This means the program depends on an abstraction first, not only on one concrete class. That makes the design clear and more flexible. It rarely reads results. I also use a static field to count how many races were created. When I record a result, I add points to the driver and store the finishing position. And this class is my static utility class. It contains only static methods because it does not need object state. Its job is to calculate the useful status for the championship. For example, it calculates the average points per driver, finds the most successful country, and counts the total number of rides held. This is a good use of static utility methods, and it also keeps statistical logic separate from other classes. So in summary, my programs satisfy the main task requirements. I could require the driver class, the rally car abstract class with two subclasses, the championship manager singleton, the race result interface with rally race result, and the championship statistics utility class. In main Java, I register drivers, simulate two races with different surfaces, switch cars between races, and finally show standings, leader, race results, and car performance. So the code is not only working but also organized in a clear object-oriented way. So let's run this code. Sorry. So you can see it from here. Finally, this is the program output. Here we can see the championship standings and current leader. Below that, we can see the statistics, including the total drivers, total races, average points, the most successful country, and total championship points. Then the detailed race results are shown for both competitions. At the end, the system also shows performance rating for different car types. So the final output matches the task requirements clearly. Thank you. These tasks help me practice object-oriented design, static members and methods, interfaces, abstraction, and a single-term partner in one complete Java program.